Good afternoon, students. Welcome to one more amazing session from Infinity Learn by Sri Chaitanya. How are you all? Can you confirm, please, whether I am able to see? You can see me and hear me? Yes, Anushka Garg, Raj, Akshay, hi. Good afternoon. How are you? Welcome to NEET Step Up 2025 program. Here we are talking about all NEET syllabus for chemistry from Suresh Avari from Infinity Learn Studio. How are you? Good, great. Nice to see that students regularly attending the classes over here and getting a benefit of these sessions. In the NEET Step Up 2025 program, we are offering physics, chemistry and biology sessions all about NEET for the preparing those students who dropped from 12th standard and studying 11th as well as 12th. So these sessions are totally benefit for your grade 12, 11 and NEET examination, my dear students. Mubina, Nafa, hi. Okay, Karthivan, hi. Nowadays you are not seen. Logivanayagam, hello. Yes, happy afternoon. Great to see you all, guys. Nice to see. How are you doing? So finally, people are waiting for NEET Supreme Court hearing and all. So it comes to an end. There is no re-NEET examination, and also you will be having a clear-cut picture about what to do for 2025 NEET preparation, right? Yes. Solman, hi. Solman, hi. Great. So where is the nominee? Now in this NEET Step Up 2025 program, मैं हूँ सुरेश अवारी, faculty of chemistry from Infinity Learn Studio, offering chemistry lectures for the NEET preparation. So in a week we are talking about first 3 days 11th standard syllabus and next 3 days 12th standard syllabus. So in this journey, and today we are going to present thermodynamics. In this thermodynamics, my dear students, I am going to let you know, all the students, let it be any competitive examination, who are preparing, the thermodynamics is going to be kind of nightmare type of topic, because this is almost about application of mathematics and physics, right? So you don't have to worry. I'm here who can give you the simplest way of learning thermodynamics. Also, I'm going to give you the best out of all tricks so that you can do the best. Hanam? Right. So if you talk about the overall thermodynamics topic, so it is directly can give you a couple of questions. One is from thermodynamics physical part, another one is thermochemistry and chemical equations part, the enthalpy of reactions, like that. So there are two questions you can expect from NEET examination, and also you will be having connection with the thermodynamics, both inorganic chemistry and other physical chemistry processes, and even organic chemistry if you go into the details of each mechanism, but we don't talk about the mechanism in the organic chemistry for the NEET examination, my dear students. So if you just generalize the overall thermodynamics, you are going to say thermodynamic terms. In this thermodynamics terms, you will be having heat, work and other category. In that we are going to say work. In that PV work graphs are important. There you can get one question from there. And also you can say the first law of thermodynamics. In that you will be talking about enthalpy and internal energy. After first law you will be having a spontaneity, and second law. After that Gibbs free energy, and after Gibbs free energy eventually we are going to enter into thermochemistry. In the thermochemistry you will be talking about Hess law, enthalpy of reaction, enthalpy of combustion, enthalpy of sublimation, and enthalpy of neutralization, and many things. And enthalpy of reaction का वजह से आपका एक क्वेश्चन पक्का निकालना है. When you talk about the mark distribution among all, you will be having a question on first law, you will be having a great questions on Gibbs free energy, you will be having a question definitely on thermochemistry. You're watching my recordings, Logmanigam, that's great. And you can give the comment also, so that I can see what is your doubt also. So those students who are able to attend my class on time, that is highly appreciated. By any chance, if you are not able to attend classes, you please watch the recording and just like and share and subscribe this YouTube channel. Is that fine? So everybody, before we going into the details of the thermodynamics, you just give a thumbs up and fire emoji, so that we just enter into a lot of enthusiasm, right? So especially those students who are studying a NEET examination, that is going to be like a toughest topic, but believe me, I am going to give you the simple tricks about all the processes that we study in the thermodynamics. Hana, you are all ready? One thumbs up and fire emoji, so that we can start. Everybody? So this is about the introduction about thermodynamics of NEET examination plan. When you want to excel in a particular course or a particular examination, you need to be having a clear-cut vision what we are going to do, right? So this is a clear-cut picture. Thermodynamics, you feel it is a vast, it is not that great vast, it is limited only. So we take these thermodynamics in a such way that in a simplest way, right? Getting ready? So all ready? Okay, Movina, solve one, fine. Logarithm, fine, right? So please engage more in the chat box, so that you can have a interactive session. It is not a radio session, it is not like a recording session, it's a live session. So you feel free to ask any kind of doubt as far as the topic is concerned. Ready? Okay, yes, that's great, that's the enthusiasm. आपको पेश कर रहे हैं अभी thermodynamics का पहला thermodynamics terms. ये thermodynamics होता है क्या पहले? So it's a branch of chemistry which deals with the heat exchanges in a physical process or a chemical process. Narayan Rao, hi, Sadhu Narayan Rao. So I just want to say, I just take a cup of coffee, hot cup of coffee. This is hot cup of coffee. So in this hot cup of coffee, this is a hotter body, and this is the surrounding is a colder body. So मैं क्या बोलना चाहता हूँ, heat is transferred from hotter body to colder body. कितना heat बाहर भेज सकता? Why only from hotter body to colder body? Why not from colder body to hotter body? So that is actually the main course of thermodynamics. Exchange of heat. Yes, always in the nature, heat is transferred irreversibly from hotter body to colder body. So that is how you have to feel it. Thermodynamics is nothing but simply deriving something, getting a formula, a question is given, apply into the formula and go into that. So that type of methodology is not at all permitted. If you go in that way, you just correct yourself, you feel it, how the dynamics is going on. है ना? Hi, Abhinav, you are 9 minutes late. 10 minutes late, Mobi. इशिता है क्या? ना, आज इशिता नहीं देख रहे क्लास में. रिचा शर्मा, अभिनव कैसे है? तो क्या कर रहे हैं? कल परसों क्या किए थे? पढ़ाई के बारे में बोलो. क्या क्या टॉपिक्स किया? सिर्फ सुप्रीम कोर्ट का वजह से वो ढूंढ रहे क्या? ओके, so happened is happened, just leave it. This is not the platform. We'll discuss, we shall not discuss about something happened with the Supreme Court and NEET 2024. So certain things you need to admit it, so which is not in our hand, is simply follow it, right? गया, स्कूल ओपन होगा, स्कूल क्या गया. सो क्या क्या टॉपिक चल रहा है स्कूल में अभिनव? क्या क्या टॉपिक चल रहा है फिलहाल? 12th में, 11th में पूरा खत्म किया? Okay, so we'll go with that. So I just want a part of universe. What is the meaning of there are three terms: system and surroundings. If you talk about this is a hot cup of coffee, we are studying how much heat is given out. So this is what you call it as a system. and this is the entire part of the universe. Universe means you don't go somewhere in the cosmic region, moon somewhere, Uranus, okay, somewhere, okay, you just see something in a defined area where heat exchange is taking place. A part of the universe which is under thermodynamic study is called a system, and this is anything out of the system in the universe is called surroundings. मैं क्या बोलना चाहता हूं, यूनिवर्स का मतलब होता है is a system and surroundings. So ये पहला कदम है थर्मोडायनेमिक्स में, है ना? This is the first foot holding step you need to know. So let's talk about the thermodynamic state of a system. ये state बोलते हैं क्या? I will tell the state. If I say something H2O, what is its state? चार्ट बॉक्स में फटाफट बोलो. गिया चांद, हाय, चार्ट बॉक्स में फटाफट बोलो. H2O इसका स्टेट होता है क्या? इसका स्टेट है क्या? जल्दी जल्दी जल्दी. अभिनव कर सकते हैं? सॉलमन, साधु नारायण राव, यस. संगीत, हाँ. What is the physical state of H2O? What is the physical state of H2O? Simple question. चार्ट बॉक्स में देना. हर बच्चा बोल सकते हैं ये लिक्विड का. हाँ, यस. संगीत, गुड आफ्टरनून. ये H2O वेपर भी हो सकते हैं, गैस. H2O सॉलिड भी हो सकते हैं, आइस. कौन सा कंडीशन में? हाँ, गीगाचंद, कौन सा कंडीशन में? कंडीशन आपका बता रहे थे, ये टेम्परेचर 25 डिग्री सेंटीग्रेड होने तो लिक्विड है, टेम्परेचर 100 डिग्री सेंटीग्रेड के ऊपर आने तो गैस होगा, टेम्परेचर 0 डिग्री का अंदर आने तो ये सॉलिड होगा. So here I just want to say there is a term called temperature decide. Temperature decide the state of physical state of the water, right? You say it is Sadhu Narayan Rao. It is said that liquid, but ये टेम्परेचर इंपॉर्टेंट है. ये टेम्परेचर के हिसाब से आपका आंसर सही होगा. H2O लिक्विड भी हो सकते हैं एंड सॉलिड भी हो सकते हैं, गैस भी हो सकते हैं. जो स्टेट बोलने का टर्म होता है स्टेट ऑफ द सिस्टम थर्मोडायनेमिक्स में. सो ये द 3 मेजर वेरिएबल्स डिटरमाइन द स्टेट ऑफ अ सिस्टम, दैट इज प्रेशर, वॉल्यूम एंड टेम्परेचर. वी कैन से प्रेशर, volume and temperature. These are the three variables decides the state of a matter. If these are called state variables. So these state variable, अगर एक वैल्यू का आप बदलना चाहता हो दूसरा तीसरा भी बदल सकते हैं, है ना? That's very important. That's very important. Don't go blindly. Got it. That's good, Sangeet. So state variable क्या होता है? State of a system. So these pressure, volume, temperature are called the state of variables because they define the state of the matter, right? So if one value is changed, एक मिनट. Yes. If one value is changed, automatically the other value is going to be changed. Good afternoon. It's not an issue. Anamani, so we can go ahead with what is happening in this class. We're talking about the thermodynamics fundamental properties and we are in thermodynamic state of a system. The state variable is the variable or a property which defines the state of a matter is called state variable. Don't worry, thermodynamics is a little lengthy process in learning. And don't worry, I am going to conduct 3-4 sessions, doesn't matter, even in this week and the next week as well. So we are going to learn in अच्छा तरफ सीखना है thermodynamics. If you open the thermodynamics book, a textbook, NCERT, that guide, this book, that college material, coaching center material, ulta fulta hota hai. So you understand one line, if you go into the second line, you will get a confusion in the third line. Hai na? So here I am in front of you, making you to understand by scratch level, from basics. Believe me, I am going to take you, you will be a master about thermodynamics at the end of the session. ठीक है? Yes, Sangeet. Very good. That's good. 3 types of system. There are 3 types of system. क्या क्या है? A system, it can be a open system, it can be a closed system, or it can be an isolated system. There are 3 systems are available in according to thermodynamics. So in the open system, this is the surface. This is the surface where it can conduct heat. So a system which can exchange heat as well as matter is called as an open system. Whereas a closed system, it can heat exchanged, but it cannot exchange the matter. So the isolated system, it is completely isolated, so that it is completely insulated and it neither exchange matter nor its heat. है ना? Giga, that's good. So there are 3 types of systems. So it can exchange matter and heat, that is an open system, open cup of coffee, right? And a closed system, it can not exchange matter, but it can exchange heat. So you can see a bottle. This is a water bottle where it is closed. You can you can't take the closed water bottle, you can't take water out of it, you can't put water inside it, it's closed. And if you keep in the refrigerator, it can exchange heat. So it's a closed system. Whereas you can see in the isolated system, it neither exchange mass and heat. So simple things, complicated things, learn in a simple way. Giga Chand, fine? Okay, Log Vinayagam. So from here we are going to study about the thermodynamics. Now let's see the thermodynamics properties. You have macroscopic properties and microscopic properties. Macroscopic properties that can be measured and that can be felt and that can be seen, right? So they are called macroscopic properties. Thermodynamics only applicable for macroscopic properties, not for microscopic properties. Okay, so you just want to see nuclear forces in the atom, the nucleus. You can't see it, you can't identify it, you can't feel it. So there you can't apply thermodynamics. Okay, you want to take a cup of coffee and it is heated or cold, so you can apply thermodynamics there. So such properties are called thermodynamics or macroscopic properties. They are mass, volume, heat, capacity, internal energy, enthalpy, entropy, Gibbs free energy, or extensive properties. I am going to talk about extensive properties in the next slide, and you can see intensive properties. So the properties which do not depend, mind it, only one, this line I am underlining here, which do not depend on the quantity of matter in the system are called intensive properties. Okay, so example: pressure, temperature, specific heat, surface tension, refractive index, viscosity, melting point, boiling point, volume per mole, concentration, color, intensity, specific energy. These are all examples. How do I know it? You just simply say example density, example density, example density. You take density of the water is 1. If you take a tank of water, you go and check the density, it is going to be 1. You take a glass of water from the tank, now you have a glass of water, again the density is 1. Tank of water 10 liters, density is 1. Glass of water 100 milliliter, density is 1. You take a tablespoon and get the water from the glass. If the tablespoon contains 10 ml, 20 ml of water, its density is 1. So with respect to of how much water you have taken, its density is 1. Samjhe? Got it? Yes. Yeah, viscosity. Sadhu Narayan Rao, viscosity of a liquid. If you take that liquid again in different size of beakers, the viscosity is same. Fluidity, are you getting or not? That's good, very good, Logovanayagam. Great. Sadhu Narayan Rao, hope you understood. So that kind of interaction is required, Logovanayagam, the independent of the quantity of the matter, not the type of matter, quantity of matter or size of matter. Got it, thank you. Right. So anything, you take the pressure of a gas, as long as the volume is constant, it is constant, right? Other parameters are constant, okay? So one more here, extensive properties. Extensive properties, the properties whose magnitude depends upon the quantity of matter, right? That's good. You take a glass of water or a bottle of water. So this is a bottle of water. The mass, the bottle of water. So let us say its mass is 1 kg. Let us pour this much amount of water in some other container and half of this. Okay, what is the mass of that? 500 grams. So if quantity is changed, mass is changed. Got it? So that I just want to say mass is extensive property. Depend on, thank you very much, nice compliments, and internal energy, total moles, volume, enthalpy, entropy, Gibbs energy, length, mass, electrical resistance. These are all the examples of extensive properties. Don't memorize this. Learn this and feel it. So how volume is changed? Volume changed, it depends on the quantity, no? Right? No, you don't say scalar quantity or vector quantity. We are not in the directional properties. There are certain things which are non-directional also, directional also in this. Are you getting or not? That's physics. This is physical chemistry. Sadhu Narayan Rao, got it? Very good to see. And Ishita is there, classmate. And the next one is temperature. Let us talk about the heat and temperature. So temperature is different thermal property which attains the same value of all bodies placed in thermal contact with each other. So temperature is a scale. This is a scale which measures the heat quantity. How much heat is there? Heat means energy. The energy is of various types in the thermodynamics. It could be electrical energy, it could be thermal energy, it could be mechanical energy, whatsoever. So we convert into equivalent to the heat. So in thermodynamics, energy means heat, heat means energy. So heat, the transfer of flow of internal energy caused by the difference of temperature between two bodies is called heat energy. Now you just see it is a hot body and it is a cold body. So this hot body and cold body, so let us say their temperatures T1 and T2. So that T1 is greater than T2. Then only heat is going to be, the heat means energy is going to be transferred from this hotter body to colder body, Solomon. So the temperature is the one thermodynamic property. Heat is thermodynamic property. Okay, temperature is a scale for that, right? Got it? Yes, very good. Kelvin. So heat is, yeah, temperature is measured in Kelvin. Kelvin scale is equal to T degrees centigrade plus 273.15 degrees. Yes. So we use any part of the chemistry, you use in Kelvin scale only. Kelvin scale only. So you do any physical chemistry or chemical kinetics, equilibrium, gas state, thermodynamics. So whatsoever you can say solutions, colligative properties, electrochemistry, temperature in chemistry, use only Kelvin scale when you solve numericals. There is no other variations. The answer may be varied with centigrade. You can convert there itself and can give the answer, right? Very good. Fine. Now let's talk about isothermal process. So what is the meaning of a thermodynamic operation, thermodynamic process? Thermodynamic process means if a system undergo a change in its state, state 1 to state 2. So what is the state? Can be gas to liquid, can be liquid to vapor, can be anything, or any PV, P1, a state, a matter is at P1, V1, T1 condition में है, and it is converted into P2, V2 and T2 condition तक बदल रहा है. So ये बदलने के वक्त में state variable बदल रहे हैं, है ना? So that one of the or more than one of the variable is changed. So that operation is called as thermodynamic process. So if a system changes from one state to another state, that operation is called thermodynamic process. The thermodynamic process can be many ways, First one आपके पास पहले isothermal process. ये isothermal process, adiabatic process, isobaric process, isochoric process and many operations are there. In the process, isothermal process means temperature is constant, my dear students. Temperature is constant. So iso means same, thermal means temperature is constant. So that change in the temperature dt is going to be 0. If you say PV is equal to nRT, is going to be constant, P inversely proportional to V, because this is constant. So that this is going to be constant. PV is equal to constant, P inversely proportional to V. So that's simple version. So from the verbal English you can learn the actual concept. P inversely proportional to V. This is the condition for isothermal process. Adiabatic process का मतलब क्या? Heat cannot be given out, heat cannot be taken in. So basic, अगर आप ये basic terms में अच्छा होगा तो lecturer or any lecture goes in a flow, you follow in a flow. Otherwise आप कहीं भी टक जाएगा, lecture जाते रहते हैं. Are you getting or not? So try to be more confident in the thermodynamic terms and the thermodynamic processes. Okay? Yes. Abhinav, again I have to call you. Full हो गया? हाँ, yes. Sadhu Narayan Rao. Okay. You are from Salman. Logvanayakam. You know that. Yes, Sangeet. संगीत कहाँ से आप? ओके, बारिश चल रहे हैं पर take care in this monsoon, and you are all NEET students, you know the biology and microbiology also. You are more prone with all kinds of infections because of the rains. Take care of yourself and stay healthy, right? Stay healthy. Indoor MP, हाँ, बारिश कैसे है इंडोर में? हाँ, yes. So adiabatic process, heat is constant, Q or heat transfer. So del Q is constant. And isobaric, iso means same, baric means pressure. So the pressure is constant and change in the pressure is constant. If you see PV is equal to nRT, nRP is constant, so by V by it is constant. Okay, and isochoric, chor means chor nahi hai, chor. Okay, so humid climate. Okay, chor. Okay, it is volume, constant volume. So that delta V is 0, P by T, PV is equal to nRT, say P by T is equal to nR by V is constant. P by T is constant. P1 by T1 is equal to P2 by T2. Yes, correct. Sadhu Narayan Rao here from Vizag. Very good. Nice to see that you are Vizag yet. Giri Pradakshina is completed. You went there, and such a nice climate with a beach. Okay. Talking about, so these are all the various processes I am going to discuss about each process there. So again, I just want to talk about, you all know this. Take a snapshot. I know that Login Agam, you are from Tamil Nadu. Pehle aap bole the. Okay. Now, great to see, nice introduction from the students, and you please attend these lectures without any fail on daily basis. So these sessions are so interactive and with a lot of enthusiastic, and if the students are talking to me like that, I am going to be more enthusiastic, and these sessions are absolutely free, right? So you need not have to move anywhere. So you please join the sessions, get benefit of this, and share with your friends so that they are also going to get advantage of this, right? Okay, great to see. Yes, you Sadhu Narayan Rao, you went to Giri Pradakshina or just participated or not? So there is a big event went there a week ago, it seems, with Sadhu Narayan Rao's hometown. Okay. Right, everybody take a snapshot of this, very important. So isothermal, adiabatic, isotonic and isobaric process, right? Very good, and let's talk about irreversible process. Understanding the irreversible process. So Sangeet, our class timings, हर दिन मेरा chemistry class में afternoon 1:30 to 3 o'clock every day. सो कल परसों नई क्लास नहीं थे क्योंकि सुप्रीम कोर्ट का हियरिंग का वजह से यूट्यूब चैनल में दूसरा चल रहा था, बट अनलेस एंड अंटिल ए क्रिटिकल और फेस्टिव डे और हॉलीडे विल बी हैविंग ए नीट केमिस्ट्री क्लास 1:30 to 3 o'clock every day till your NEET 2025 examination. So we are going to discuss about the concept and the questions as well, and we'll be having specialized customized classes with NEET preparation, only multiple choice questions, formula review classes, and expected questions and expected corners, everything will be discussed. Sangeet, is that fine? Right, stay tuned. The class is going to be up to 3 o'clock. Don't leave the session so that you leave the tempo if you leave it. So this is for you and it is for your benefit, and you all follow this. Understanding irreversible process and a reversible process. What is the meaning of irreversible process? Let us say this is a cylinder. In this cylinder we have a piston over here, and this is your piston, right? And we have a gas over here. So gas exerts some pressure here. So this is what you call it, the pressure of the gas. And you are also having external pressure PATM. एंड द वॉल्यूम आपको कितना दिख रहे हैं पर V1 तक दिख रहे हैं, है ना? V1 तक दिख रहे हैं. I am from Sadhu Narayan Rao, Hyderabad, Infinity Learn Studio, and I am more connected with Visakhapatnam. That's why these many questions I'm asking you. Okay. Anyways, so my condition है कि है पर मान लो आपका pressure of the gas, एक्सटर्नल प्रेशर एटमॉस्फेरिक प्रेशर से ज्यादा हो, क्योंकि ये जीत गया ना. आर यू गेटिंग और नॉट? पिस्टन राइजेस अप, पिस्टन राइजेस अप. अगर PATM, P गैस के ज्यादा होने तो पिस्टन विल कम डाउन, कंप्रेशन होगा, एंड यहां पर पिस्टन रेज होगा, एक्सपेंशन ऑफ द गैस. Are you getting on? I don't want to use complicated terminology. इसी के कारण आपका लिखा हुआ piston raises up. Piston is going to be raised means gas expanded, है ना? Expand करने का वॉल्यूम बदल रहे हैं. So आपका वही यहां तक होगा. कब तक? So जब pressure of the gas is equal to pressure of the ATM, तब तक ये वॉल्यूम एक्सपेंड करते रहते हैं. कैसे? सिंगल स्टेप से जा रहे हैं. So I just want to say this becomes V2. So this state V1 से V2 तक जा रहा है ना, ये जाने के वक्त में कितने बार पिस्टन रुकेगा? कहीं नहीं रुकते, सिर्फ एक स्टेप में it is expanded. So the process that takes place from a state P1 V1 से V2 तक, ये सिंगल स्टेप में जाना है. ये सिंगल स्टेप प्रोसेस, that is a process which takes place in a single step, is called irreversible process. Are you getting or not? Clear? Getting or not? Yes. It is easy to observe and easy to achieve. Easy to observe, है ना? Equilibrium is observed. In initial and final stages. Initial and final stages. This is about irreversible process. I think, hope you all understood this. Now the same process we are going to see in the reversible process. Yes, reversible process. Let's talk about the reversible process. उसमें कुछ doubt है क्या? नहीं है? Okay. Let's talk about the reversible process. So the same experiment. So the same experiment, I just want to make it complicated. कैसे? कुछ कॉम्प्लिकेट नहीं है, कॉम्प्लिकेट के जैसे आप मान रहे हैं, है ना? उसमें ऊपर थोड़ा मिट्टी डालो, some kind of sand, some sand. This is what is called sand. Okay, this is sand. And this is the volume V1. And when you just remove one sand particle, so when you remove one sand particle, what happen? Initial stages, यहाँ पर आपका P gas is equal to, almost equal to P external. This is what you call it as a P external, and this is what you call it as a P gas. समझे? P gas. समझे? Yes. Atul Verma, God bless you, beta. Yes. Sadhu Narayan Rao, listen. So when you remove a small sand particle, theoretically and experimentally, but you may not visualize it, little bit of external pressure is removed, so that little bit of movement of the cylinder can be seen carefully. So पहले यहाँ था piston, अभी तो थोड़ा सा ऊपर लगे, right? So volume कितना दे रहे हैं? This is a small change in the volume. Are you getting or not? dV. पहला जो है, पहला यहाँ था, and this is what you call it as delta V. Yes, संगीत, okay, आपके लिए मैं रुकना है क्या? So I'll just go with the flow. You can come and join, right? Doesn't matter. So what I mean to say, whenever this goes like this, yes. So you keep on removing the particles like this, particles like this, particles like this, particle like this. Finally, all sand particles are removed. You are going to take the volume V2. Okay, it is changed V1 to V2 in how many steps? Several steps. Yes. So the process takes several steps. Kitna? How many several steps? infinitesimally small several steps it takes place. है ना? That's very 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 important. So kind of process is called reversible process. And और एक चीज है, equilibrium is observed at every step. So many equilibriums can be seen. Many equilibriums can be seen. And Atul Verma, it is true. And maximum work done is going to be maximum. Work done is going to be maximum. That is a specialty in the reversible process, and it is difficult to achieve it and difficult to imagine it also, because you just see you only put sand particles and you ask it to remove sand particles like this. It's practically it is not feasible. Initial and final stages are yet in this process. Yes, it is there. Initial is there and final is there. Between initial and finally you can have infinite number of steps, right? This is called reversible process. When the reversible process is done, work done is maximum, right? It is the way you understand thermodynamics better, and thermodynamics is actually easy if you understand. If I use all technical terms at a stage and you just blast the entire class, you feel that you understand, but you never apply on the concept. Yes, that's good, very good. So any doubts? Let's go into the internal energy. Internal energy hai kya? Anybody knows about internal energy? Anybody knows about internal energy? So let's go internal energy. So internally we have so many feelings, but we never express it. You can't see it also. Similarly, a system has so many types of energies. Potential energy, sum of different energies, log Venn, correct. So potential energy, kinetic energy, okay, and thermal energy, rotational energy, vibrational energy, many types of energies. So all possible forms of energies that are associated with the system are referred to as the internal energy. It includes kinetic energy due to all kinds of motions, vibrations, rotations, oscillations, kind of, and their potential energy, and due to stability, intermolecular forces also play a crucial role on that. So log Venn, you know about the intermolecular forces better. Intermolecular forces, van der Waals forces, dispersion forces, dipole forces, London dispersion forces, ion dipole forces, ion forces, dipole forces, induced dipole forces, hydrogen bonding, everything, right? Great to see that. Yes, yes. So actually this is internal energy is indicated by a letter U or E, doesn't matter. In some books it is E is written, some books it is U is written. Absolute value of any thermodynamic state matter state function cannot be determined. So but the difference can be measured. You can't measure the absolute value of internal energy. You can check the internal energy change like delta U is equal to U2 minus U1. Internal energy initial state, internal energy final state. The change you can measure but not its absolute value. So van der Waals forces. Okay, right. So the internal energy change of a system depends on the state of a system and not how it is changed. So you have two properties. I just want to say state function and the path function. State function is defining as a state, and it depends on initial as well as the final states, and do not depend on how it is changed. Do not depend on how it is changed. Path function depends on initial and final, and also how the state changed. So how the state is changed? Let us take electrical energy is a type of energy, okay, and electrical energy can be connected to thermo refrigerator, so that you are converted into thermal energy. That electrical energy is connected to ceiling fan, so that it is converted into mechanical energy. Okay, it is connected to a light, so it is electrical energy is converted into a light energy. So that the path of the change in the heat or the energy, electrical to thermal, electrical to mechanical, electrical to light. So that is what you can say path. Are you getting or not? Yes. Yes, thank you so much, sir. I will meet you again in the next class. You like this class? One thumbs up and fire emoji. Sadhu Narayan Rao, I just want to know your complete name. So here the best examples for the path function is simply to heat Q and work W. Only two. Yes. Yes, heat and work. Rest of these two, all others are state functions. Are you getting or not? No. So all are going to be the path functions and the state functions. Are you getting or not? Fine. So let's go ahead with that. Now other examples of temperature, pressure, volume, enthalpy, entropy, Gibbs free energy. If U1 is internal energy change, internal energy of a system, and the state 1, and ut is the state 2, then the change in the internal energy of the system is given by u2 minus u1. That's the same one. Got it? Sadhu Narayan Rao. Okay, so let's go ahead. Now let's talk about a state. I just want to say delta u is depend on the process which takes the system from the state 1 to state 2 only, but not on the path. It's a state function, right? Now let's talk about first law of thermodynamics. Everybody can say there are Parigala Rahul. Yes sir, make a video on 9 months strategy for August to May for NEET 2025. Today only you want me to make it? Okay. Tomorrow we'll be having a discussion. In that I will discuss about the strategies. Definitely I will going to talk near about 10 to 15 minutes about that. Tomorrow 1:30 I will discuss about your context, Parigal Rahul, and we'll talk about what I say solutions on colligative properties, one shot total formulas I'm going to make it. And after that I just want to discuss multiple choice questions on solutions on a stretch for a single session on Friday. And Saturday you will be having general organic chemistry expected questions from NEET examination. Expected questions for NEET examination, general organic chemistry, so that a round of overall revision. यही है NEET step up 2025 का strategy है, so that you all without miss you just join 1:30 to 3 o'clock every day. You will be raised. You will be raised in your career perspectives, in your preparation, and you will be getting a very good score, and you can be a topper if you follow my sessions without any fail. So thank you. Let's go ahead. First law of thermodynamics. So उसमें ज़्यादा jokes भी है first law. Okay, you can define it many ways. So it is nothing but law of conservation of energy. So energy you can't destroy, energy you can't generate it. Rather ये एनर्जी एक फॉर्म से उतना ही एनर्जी, जितने एनर्जी पहले था उतने एनर्जी दूसरा फॉर्म में बदल सकते हैं. Are you getting on? So you neither create nor destroy energy, but it can be changed from one state to another state. The energy neither be created nor destroyed, although it can be transformed from one form to another form. So I just want to say many ways this can be done. If some quantity of energy in one form disappeared, the same quantity of energy in another form should appear. Got it? Parigal Rahul? And also, it should also talk about energy and work are interconvertible. If energy of some quantity of energy is disappeared, equivalent work should be performed. This is another. So I just want to say energy and work are interconvertible, my dear students. Sadhu Narayan Rao, है ना? Energy and work are interconvertible. I just want to say it is impossible for me, जो भी मिशन मान लो आपका, so बिना एनर्जी ले काम नहीं करता, है ना? So it is impossible to construct a machine, a perpetuate machine which can work continuously without supply of continuous energy. सर मैं बाइसिकल चलाता हूँ, सर बाइसिकल चलाता हूँ, so जोर से दबाओ, so you don't pedal it so that it can go like that. So that is not against the first law of thermodynamics. ये momentum का वजह से जा रहा है ना? So it can't go for infinite distance ना, it will go तब तक जब तक ये momentum इसके पास है ना? Yes, that's good. So if it is impossible to construct a perpetuate machine which can work continuously without supply of continuous energy, है ना? That's the actual incident of the first law of thermodynamics. So without first law of thermodynamics, no machine, every body, every machine, everything in the universe should follow first law of thermodynamics. Okay, we don't talk about the zeroth law of thermodynamics because in the chemistry we don't need it. It is there in thermal equilibrium का वजह से, in physics also, but we don't talk about in chemistry. In chemistry we talk about first law and second law and spontaneity तक है. Zeroth law and you talk about the second law in physics, more about entropy kind of things. Okay, right. So you just give kind of interactive gestures in the chat box so that I will be having an idea about how the students are following in the class. Okay, so that the transaction between you and me should be in the two ways, right? So very happy to see hundreds of students are there in the YouTube platform. Now they are getting benefit out of my lecture and really enjoying. एक बार thumbs up and fire emoji दाना session में yes like भी मार सकते and तुरंत आपका फ्रेंड्स का ये वीडियो शेयर करना एंड आप सब्सक्राइब करेंगे तो आपको भी ये सेशंस का अपडेट मिलेगा. ये डिस्क्रिप्शन बॉक्स में आपका टेलीग्राम चैनल का लिंक दिया, ये लिंक में आपका ये क्लास का जो नोट्स बना रहा है मैं आपको पीडीएफ फॉर्म में मिलेगा, है ना बेटा? संगीत ज्वाइन किया? राइट. परिगल राहुल, लॉग मेनाइगम, यू आर वाचिंग द रिकॉर्डिंग्स. whenever you watch the recordings, at least comment box में something you write it, like you understood and you have some doubt in that particular area, so that every comment I am going to honor it, right? So you can rewatch those and you can get the correct answers for that, right? So let's talk about, let's say if we supply an amount of heat Q to the system of state 1, the system does some work, goes to the achieve the state 2, the heat supplied to the system gets converted in two parts: work done by the system, change in internal energy of the system, है ना? Yes. So what happens when work done by the system and internal energy is also changed? Well, follows this law of conservation of energy. So this is what you call it as mathematical form of the first law of thermodynamics. So you may be wondering, sir, what is there? उसमें खास बात कुछ नहीं है बेटा. This is a system बेटा. This is a system. सिस्टम का पहला जो इसका इंटरनल एनर्जी U1 है ना? सो इसका कुछ करना चाहता हूं मैं. इसका थोड़ी सा एनर्जी दे दो, ओके, क्यू एनर्जी इज गिवन, उसमें थोड़ा सा वर्क भी कर दो, वर्क इज डन, ताकि इसका इंटरनल एनर्जी U2 तक बदलेगा, है ना। सो क्या होगा, U2 इज इक्वल टू, पहला इसके सामने U1 था, हम कुछ दिया, Q इज द हीट गिवन एंड कुछ काम भी किया, है ना, समझे, सिंपल थर्मोडायनेमिक्स इतना ही है। सो दैट U2 माइनस U1 होगा Q प्लस W। वी नो दैट डेल्टा U इज इक्वल टू U2 माइनस U1 था, सो दैट U2 माइनस U1 डेल्टा U इज इक्वल टू Q प्लस और माइनस W है। दिस इज व्हाट इज कॉल्ड एज फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स। होप यू अंडरस्टैंड, इतना सरल है, यू डोंट हैव टू वरी अबाउट दिस। सर क्या प्लस और माइनस क्यों लिखा है सर, यह मेरे सवाल है, नहीं, अगर काम करने दो, इफ सिस्टम डज द वर्क और somebody is doing work on the system, very good log बनाएगा। so W is going to be negative, W is going to be positive। W नेगेटिव होगा कब है, W नेगेटिव होगा तब वर्क डन बाय द सिस्टम, एंड W पॉजिटिव कितना कब होगा, वर्क डन ऑन द सिस्टम। अगर सिस्टम खुद काम कर रहे हैं, दैट इज वर्क डन बाय द सिस्टम। और कोई सिस्टम के ऊपर काम कर रहे हैं, वर्क डन ऑन द सिस्टम। ये नेगेटिव और पॉजिटिव मेरा वजह से नहीं है, IUPAC का वजह से। आप ये इस्तेमाल कर, फिजिक्स में अलग होता है, इसका उल्टा होता है। क्यों उल्टा होता है, दैट्स अ डिफरेंट मैटर। दे टेक द सिस्टम एज we take the entire thing as a system, but they take in matter as a system. That's the reason why that makes the difference between the physics and chemistry. But IUPAC chemistry यही sign conversion आप इस्तेमाल करना बेटा। Are you getting or not? Clear? Do you feel thermodynamics is difficult or easy now? You all give that in the chat box. जल्दी बोलो, thermodynamics आप easy लग रहा है, difficult लग रहा है अभी? इजी लग रहा है, डिफिकल्ट लग रहा है? का लॉग बनाएगा संगीत, राहुल? यस, नाउ थोड़ा आगे बढ़ना है। यस, ओके। So the first law of thermodynamics can be understood with the help of the second laws. So the energy in a process may be transferred from one form to the another form, but neither be created nor destroyed. That is the first point. Or you can say, in any process, the sum of the energies of the system and surroundings is constant, the total energy of the conserved in the given process. And also you can say, a machine which operates in cycles and produces work without any expenditure of energy on it's called as a perpetual machine. Technical term, perpetual machine. And the first law of thermodynamics rules out the existence of motion machine of kind of first. So I mean to say, that is a complicated statement, it is simple. It is a perpetual machine which can work, means continuously without supply of energy. This is what is said. Okay. Next, first law of thermodynamics is known as law of conservation of energy. The mathematical form we derived as delta U is a Q plus W. Here the sign conversions are important. Jyoti, Vidwal, sir, second law of motion. This is not law of motion, law of energy. Jyoti, fine. It is not law of motion. Okay, let's talk about heat absorbed by the system or work done on the system is always positive. System का कुछ फायदा हो रहा है ना? Yes, it is. And heat given by the system or work done by the system is negative. So a sign conversion important है. If you solve a question without knowing this sign conversion or by confusion in the sign conversion, you are going into the you know the concept, you are doing correct, तो साइन कन्वर्शन की वजह से आपका आंसर गलती भी हो सकता है ना बेटा? नाउ एंड इफ द हीट absorbed by the system and work is done by the system is q e plus q and minus w, right? And the ulta, if the heat absorbed by the system and work done in the system on the system plus q plus w. हाँ, सेकेंड लॉ ऑफ मोशन फिजिक्स में है ना, राय सर वही बोला है, आई थिंक 4 बजे का क्लास है राय सर का. हाँ ओके, ये एक केमिस्ट्री क्लास है, सो फिजिक्स का डाउट हम देने तो नहीं अच्छा होगा, राइट? ओके, नाउ let's talk about if the heat is liberated by the system and work is done by the system, delta is equal minus q minus w, है ना? Right. Now if the heat is liberated by the system and work is done by the system, q minus q plus w होगा. And the heat changes in a system can take place at constant volume or constant pressure. And I just want to give you, let us say this is a system and this is a system. In this system heat is going on, heat is going in, q is going to be plus. This is a system, if the heat is coming out and आपका q value negative होगा, right? Jyoti Vaidar. And this is a system, if somebody is doing work on the system, W is going to be positive. If the system, work done by the system, W is going to be negative. इतने खास बात नहीं है. So understanding Q पॉजिटिव होगा, कब पॉजिटिव होगा, कब नेगेटिव होगा, वर्क कब पॉजिटिव होगा, कब नेगेटिव होगा, यही आपका इलिस्ट्रेशन. तैयार है? क्लियर है? अभिनव? यस, दैट्स ग्रेट logarithm. Now let's talk about IUPAC conventions. According to IUPAC, if the process is carried out at the constant volume, no mechanical work is done, V is constant, then therefore dV is equal to 0, W is going to be 0. dV is going to be 0, W is going to be 0, right? And also you can say from the first law, if the process is carried out, applications of the first law we are talking. If the process is carried out at a constant pressure means change in the pressure is going to be 0. So volume of the system changes if the work done and the pressure work W is denoted by PdV. So it is going to be, therefore if the process is carried out constant pressure, that is what you call it as isobaric process. That's good. In this isobaric process, U2 minus U1 is equal to delta U is equal to QP minus P delta V. So QP is equal to QP minus P V2 minus V1. So QP minus P delta V. You can say QP minus P delta V. You can say that. So we are not deriving anything. We are not deriving anything out of it. Okay, that's what. We are just applying the first law in a different process, in a different methodologies. It's a quite simple. So QP is the heat absorbed at constant pressure. Heat at constant pressure. So ऐसे समझाना है. संगीत fine. Rahul, that's good. Let's go ahead. And और एक चीज है, U P delta V is called enthalpy, is denoted by H, and enthalpy means Greek to warm in. Array, everybody knows what is enthalpy, for it is derived from the Greek letter warm in, enthalpy. Actually, there are two things, internal energy and enthalpy. The heat content at constant volume is called internal energy. सारे के सारे process on the globe, you can see it is against to the external constant pressure. मान लो 1 bar. So we need one more thermodynamic property which can define the amount of heat at constant pressure. That is what you call it as a QP. That is heat at constant pressure is called enthalpy. Right, beta? Right. That's good. So the एक तरीका है, ये thermodynamics सीखने के तरीका है बेटा. Don't go into details about the mathematics. Of course, the thermodynamics is nothing but physics, more about mathematics. If physics is my subject and mathematics is my language, kind of statements I have to use. But those concepts we are using in chemistry, so it is a physical chemistry where we are going to talk about the enthalpies in the chemical reactions. There you can see. Okay, so that is nothing but enthalpy is equal to internal energy plus PV work done. So if you change H, so since QP is equal to H2 minus H1, then UPV or state functions, H is also a state function. So delta H is equal to U plus PV, delta H is equal to U delta U plus P delta V. Then why not delta P? There is no change in the pressure. There is no change in the pressure. So pressure is constant. So we know that PV is equal to nRT. Now P is a constant, change in the volume and change in the number of moles RT. ये बहुत important है. I am going to discuss what is delta N there. What is delta N there? Delta N is equal to, very important, delta N is equal to sum of the number of moles of the gaseous products in a chemical reaction minus sum of the number of gaseous moles of the reactants. यहां से आपको सीधा निकाल सकते हैं अगर डेल्टा एन इज इक्वल टू 0. इफ डेल्टा एन इज इक्वल टू 0, अगर डेल्टा एन ग्रेटर देन 0 होगा, मान लो डेल्टा एन लेस देन 0 होगा, अगर डेल्टा एन 0 होगा तो डेल्टा एच इज इक्वल टू पी डेल्टा वी. डेल्टा एन ग्रेटर देन 0 होगा तो यू कैन से यहां से डेल्टा एच इज ग्रेटर देन डेल्टा यू. Here delta U. If delta n less than 0 होगा तो delta H is less than delta U. That's very important. You can take how to calculate this delta n. I already given ना. ठीक है, अगर एक केमिकल रिएक्शन आने तो आप पकड़ सकते हैं ना, आपका क्वेश्चन दे सकते हैं, आप कर सकते हैं, है ना. राइट. नाउ लेट्स टॉक अबाउट द अदर प्रोसेस इन थर्मोडायनेमिक्स. If work done by the system is taken as a positive, work done on the system is taken as negative, and heat gained by the system is taken as a positive, heat lost by the system is taken as a negative, right? And increase in internal energy taken as a positive and decrease in internal energy taken as negative. So thermodynamics में ये important चीज़ है. ये thermodynamics में ये साइन कन्वर्शन का पकड़ के आपका प्रोसेस चलते रहता है ना बेटा. वेरी गुड. लॉग बनाएगन. होप यूर अंडरस्टैंडिंग. सो डियर स्टूडेंट्स, यू कैन आस्क एनी काइंड ऑफ डाउट्स. परिगल राहुल, संगीत, ज्योति विद्वाल, लॉग बनाएगन. Abhinav, Ishita, I think yes. Now let's talk about work done and internal energy. So work done means many works are there in the PV work, you can say. When the piston, this is your cylinder, this is your gas, this is your gas, ideal gas, मान लो ये ideal gas का है. When the piston external pressure P is equal force upon area is given, so that if the P gas is more than external pressure, the piston is going to rise up. So there is a change in the volume, you can say, right? Change in the volume, you can say. That change in the volume, you can say, suppose we have a gas confined in a cylindrical container with a movable piston. It is given in a system where F is the force and A is the piston area, since the pressure is defined as the force per unit area. So according to that, yes, work is defined as the force applied over a distance. So if the piston moves distance delta H, expansion takes place, and then work is done as work is force into distance. So force is F, and which F? That external force, right? And delta H is equal to change in the volume. Simple. Now in the change in the volume, if work is going to be P A delta H. So in this P A delta H, we can say change in the volume, delta V is given as initial volume. Let's say this is volume V1 and this is volume V2. So that delta V is equal to V2 minus V1. है ना? In this V2 minus V1, you can say, so the substituting this delta V is equal to A into delta H. Okay, delta H is equal to P delta V. So work done is going to be P delta V. So P stands here external pressure. This is your external pressures. समझ में आ रहा है क्या? Great number of students. Good students. Right. Now let's talk about the work, compression work. When the piston rises, that is called expansion. When the piston moves down, that is called compression. ये चीज में अब देखो expansion. So piston is raised, volume बढ़ते जा रहे हैं, expansion. अगर volume कम आ रहे हैं ना, the same work should be done, compression work, that is called initial volume final less than volume initial, P external minus delta V. You can say that it is work done on an ideal gas in a cylinder compressed by external pressure. P external is given this. Okay, in the previous diagram we have taken the cylinder like this. Now we are taking the cylinder like this. Now that is a pressure and a volume. If the compression is happening, the graph should go in this way, and expansion is happening, this is called compression. If the graph goes like this, is expansion. So the shaded area, you can take the shaded area. This is the area can give you from the graph, that is nothing but work. For मान लो any PV graph, the area of the shaded part is going to be the work done. Now you can say work done on the system on compression work in the reversible process is given W irreversible is equal to minus P external delta V. Delta V is equal to V2 minus V1. है ना बेटा? That's great. We are rising in the PV work. Okay. So if the compression occurs in the large number of series of steps, that is large number, the large number reversible, and a single step, that is irreversible. We discussed irreversible होता है and reversible होता है. So irreversible single step, reversible several steps. That is given as taken as, we can say directly. I just want to give, we have to integrate from several steps now. Each and every step has to be integrated, and taken differentiation, and these differential steps are going to be integrated from initial state to the final state, so that W reversible, work done reversible, you are integrating from V1 to V initial to final, P initial dV, small change in the volume, so that PV is equal to nRT, so that minus integral V1 VF initial final nRT dV by V. So this is given as minus nRT ln ln F V final upon V initial. So here I just want to, ln is equal to minus 2.303 nRT log V F minus Vi. So I just want to rewrite this, V reversible is equal to minus 2.303 nRT log to the base 10 of V2 minus V1. This is what I want to say. Got it? Got it? And if you so maximum work done is done in the reversible process, so you have to check over what formula you are using, reversible formula or irreversible formula. Okay, you can say expansion work, that's what we discussed the same way. PV plots, pressure and volume according to Boyle's law, P is inversely proportional to 1 by V, PV is equal to constant. If you just say P and V, it is going to be rectangular hyperbola. This is your rectangular hyperbola. है ना? Got it? That's way. Okay. So although it is changing V initial and V final, and if it is going like this, it is expansion. It is going like this, it is compression. In this way, the area of shaded part from this state to this state is called as work done. Mind it, area of shaded part. Everybody got it? Now that is for the reversible process. We integrated, we got it is W reversible is equal to minus 2.303 nRT log Vf by Vi. So you are going to get a simple steps, है ना? So that you are going to get, yes, you are going to get from this is the simple dV change, this is the change dV, and this is the change dV, this is the change dV, and this is the change dV. Small steps, है ना? Several small steps, and you are going to check V1 to V2. This is what you call it as an irreversible process. Got it? It is about irreversible process. Now PV plots, these PV plots are very important, and for isothermal reversible change, Q is equal to minus W is equal to nRT ln Vf upon Vi. Q is equal to 2.303 nRT log Vf by Vi. Now free expansion. Let's talk about the free expansion. In this free expansion, free expansion of a gas into the vacuum. So I just want to say here W is equal to minus P delta V. For free expansion, for a vacuum, external pressure is going to be 0 because it's a vacuum. If you put P external is going to be 0, work done is going to be 0. इसमें कुछ खास बात नहीं है. It's very simple. It's very simple. Got it? It's very simple. P external is going to be 0, and for the free expansion, work done is going to be 0. Agree with that? Clear? Okay. Very good. Now yes, this is about the reversible process. The reversible process takes in several steps, so that if you take the pressure and the volume, you take a small change in the volume, small change in the volume, small change in the volume. So from integrating from Vi to Vf, we are going to get W is going to be minus 2.303 nRT log V2 upon V1. So this is the work done, and if it is work done by the system, it is expansion. Negative work done on the system, it is a compression, it is going to be positive. Very good to see great number of students in today's class. Today we discussed, just started thermodynamics, and we all seen all kinds of technical terms used in thermodynamics. Raj, yeah, no Google Meets, only YouTube's, and you have the hit like button and share with your friends and subscribe to the channel. And my dear students, in the next classes we are going to discuss about the extension of thermodynamics here, and tomorrow we will be having a discussion on total solutions and colligative properties in one shot, and the next day we are going to do multiple choice questions, expected NEET questions from the solutions and colligative properties. We are here to learn something to improvise our rank. For that we are taking the live sessions, and also you have rank betterment program in the Google form, link is also given. You can all join in that, so that you will be getting the benefit of that. And tomorrow we'll meet with more stuff. Today we had a great swell off session of 90 minutes with thermodynamics, and get ready every day 1:30 to 3 o'clock, 2 hour sessions without any fail, my dear students. So signing off, Suresh Avari from Infinity Learn. Please like this session and subscribe to the sessions YouTube channel, and if you like it, share with your friends. Thank you. Signing off, Suresh. Bye bye.